Y'all, Barely Beverage Jr. for physics. We'll get started momentarily. Hello, everybody. Earlier this week, I was talking about gravitational potential energy, and I was unclear about the units. I said I would ask my professor about that, and I did. And the solution is pretty simple and straightforward. So it turns out that gravitational potential energy, the units are meters squared over seconds squared. And he showed me a pretty cool way to get the units of G by using, what do you call it, dimensional analysis. So for instance, if we take F equals G M over R squared, and we take these and solve for G, we can say F R squared over M equals G, which equals the force is in newtons, the R, the radius is meters squared, and the mass is kilograms squared. And newtons is kilograms meters per second squared. So this is kilograms meters per second squared, meters squared over second uh, over kilogram squared. And plus we have our units for G. Put it in different ways. We could also G. So I was concerned about the units for G. So let me see if I can get it in the exact form that uh, meters cube over kilogram second squared. And that's it right there. So we have meters cubed, which is these 3 meters here. We have this kilogram and this kilogram will cancel, leaving just 1. So second squared kilograms. So we see that the units for Newton from um, uh, Britannica was right. That's the first thing. Um, Another thing we can do is add this more closely. So we know that this is meters cubed over second squared kilograms. And we know the mass is kilograms and the R is meters. So these will cancel. One of these will cancel. So the gravitational potential energy is meters squared over second squared. So pretty straightforward. But still, I think odd to think about that meters per second, meters squared over second squared. is the units of gravitational potential energy, right? And then we can do like we did up here and multiply various things in, like multiply kilogram or to start to make it into joules. So if we just multiply kilogram over kilogram, and we end up joules is kilograms, meter squared over second squared. So we have joules per kilogram, um, and so on and so forth. If you take out one of the meters, then you do get newtons, meters over kilograms. So those are the units because newtons is kilograms, meters over second squared. So you have to take out 1 meter. All of these are the units for gravitational potential energy. So that was quite interesting. But the units work. So it's another set of units that I learned. Um, answers came out right, and it's awesome that we can do these calculations and everything adds up like it should. Um, another interesting thing that I spoke with my professor about is that when you take these values, let me see if I can find the value for the sun at the Earth. I believe it's this one. Sun at the Earth surface. So this should be the value for the sun at the Earth's surface if I'm picking the right one. So I equals meter squared over second squared. Now, if I take a square root of the gravitational potential energy, let me get my calculator. Unfortunately, I don't have, I may not have the exact numbers in the calculator anymore, so it won't be accurate. At least not, at least not like it would have been the same day. But you'll still get the idea. So I'm going to take the square root of this, the square root of the gravitational potential energy. No, just like I have here, so again, it won't be precisely accurate. Square root 8.87 times 10 to the 8. And what I get is 22.98 e to the 4 meters per second, which equals 29.8 kilometers per second. And do you know what this is? This 29.8 kilometers per second is actually the speed of the Earth around the sun. So the gravitational potential energy actually gives us the natural orbit, natural orbital speed at that gravitational potential energy. I think that's awesome. And so this gives us the the speed of the Earth around the sun because of the gravitational potential energy of the sun at the Earth's surface or Earth position in the solar system. And conversely, if we do this for Earth at Earth's surface, we get the speed of a satellite orbiting Earth at low orbit. So that's quite amazing. So that's an interesting connection that I wasn't aware of. And thus, we see more clearly why the units are meters squared over second squared because their gravitational potential energy has a direct relationship to the speed of an orbit at that distance from the gravitational body, the gravitating body. So awesome. Hope you all found that interesting. I want to come back and close that loop. And I'll be back next week with some more physics, math, astronomy. Maybe I'll go into some cosmology next week or maybe some thermodynamics. We'll see. Thank you all for watching and joining. Like, subscribe if you haven't already. See you next time.